consider this function. First of all, find the vertical asymptote. Well, vertical asymptotes happen when the denominator, which is in this case x plus 2, are equal to 0. So that means x is equal to negative 2 is our vertical asymptote. Find the axes intercepts. So first of all, let's find the y-intercept. The y-intercept is when x is equal to 0. So that is f of 0. So we end up with minus 9 over 2. So the y-intercept is 0 minus 9 over 2, or minus 4.5. The roots are when the function is equal to 0, so f of x is equal to 0, which means 0 is equal to our numerator. This is a quadratic which we need to solve. We can factorize this one, and we get 2x and x, and minus 3 and plus 3 gives us 6x minus 3x, gives us the minus 3x that we need. Sorry, the plus 3x that we need, which means that x is equal to 3 over 2, or x is equal to minus 3 are our two roots. Maybe we prefer to write them as coordinates. So that would be 3 over 2, 0, and minus 3, 0. Find the oblique asymptote. So this is the bit that's new for this type of function. To find oblique asymptotes, we have to perform the polynomial division. So we've got x and 2, and we know we have 2x squared, which means this one needs to be 2x. If that's 2x, this is 4x. But we only want 3x, so this has to be minus x, which means this is minus 1, which means this is minus 2, but we want minus 9, so the remainder is going to be minus 7. Now actually the remainder doesn't matter. All that matters for the oblique asymptote is the quotient. So the oblique asymptote is going to be y equals 2x minus 1. Now that we have all that information, let's try and sketch the graph. So first of all, I'm going to put in my axes. I'm going to put in quite large axes here, so we've got plenty of space to sketch this. Now we said that the vertical asymptote was x equals negative 2. So we've got a vertical asymptote coming through at negative 2. We have an oblique asymptote going through at 2x minus 1. So 2x minus 1 is going to come down something like this. Passes through at minus 1 there. It's going to pass through at a half there. Now the roots. We saw that the roots were negative 3. So there's a root there at negative 3. And the other root was at 3 over 2, which is going to be about there. So it has to approach these points. Oh, and we also knew the y-intercept. The y-intercept was at minus 4.5. So that's going to be somewhere around about here, minus 9 over 2. So it has to approach these two lines and go through these points. Okay, well that's going to mean that this one here is going to sort of approach, well up here it's going to approach this line. And then it's going to come through, and then it's going to approach down here. So it's going to come up from that line there. It's going to go through there, and as it goes up further and further, it's going to approach this line there. Now it shouldn't be curving that way. This is not a particularly great sketch for that one. Now this one's going to come down here. It's going to go through, and then it's going to come down and approach that one there. So I'm going to move that root there to make that fit. And I might also move this root over here. I think actually having those positioned there has made it harder to do this. It's going to come up, and it's going to, let's try and make it a smooth curve, come up and approach that graph there. So if we say that's the 3 over 2, doesn't really work for the scale, but it's okay for a sketch. And that's the minus 9 over 2. Knowing where the roots and the y-intercept were, and knowing that it has to approach those asymptotes, helps us see where things could be. It could also have been inside here, which would have been easier to draw if the roots had been inside between these, but because they are not, it's got to approach it from these sides. But it's got to approach both asymptotes, got to go through those points, draw the line as best you can to make it fit.